Good afternoon, everyone. I'm Ming Xiang from PB's Technology Department. Today, I'll be bringing everyone through PB's problem statement on the recovery of phosphorus from our wastewater treatment streams. This will help to improve Singapore's food security in the long run. Today, Singapore is heavily reliant on the world for its food needs, with more than 90% of our food imported from other countries. Under the new 30 by 30 vision, Singapore aspires to build the capability and the capacity of our agri-food industry to produce 30% of our nutritional needs sustainably by the year 2030. In addition, we've identified hydroponics as one of the more promising agri-tech that can help speed up the growing cycle of our homegrown crops locally, considering the land scarcity issue within Singapore. However, food security remains a challenge for Singapore as we do not possess any natural phosphorus rock reserves for agricultural use. Being a critical yet non-renewable resource, so we have to rely on phosphorus imports from other countries, and this exposes us to global volatility in supply and prices. In addition, there are also reports citing that the global reserves in phosphorus are expected to be depleted within the next 50 to 100 years' time. As such, we are interested in looking for collaborators to provide sustainable and cost-effective solutions to help PUB recover phosphorus from our municipal use water treatment waste streams so that it can be used in local hydroponic fertilizer solutions. PUB has done an internal study and identified 3 potential sources of phosphorus in our use water treatment waste streams that can be recovered. This includes our dewatered sludge stream, our dewatering centric stream, and also our sewage sludge incineration ash stream. The indicative quantity and concentration of the phosphorus available at each of the waste streams is provided in the slide deck. Okay, this slide here outlines the location of the 3 waste streams within PUB's use water treatment process. Okay, firstly, you have the dewatered sludge stream, which is the solid waste stream produced from the dewatering centrifuge. So this is the unit that is represented here. From the same unit, you also have a liquid stream that is sent back to the headworks. This is referred to as your dewatering centric. Eventually, the dewatered sludge will be sent for incineration, and as part of this incineration process, you also have sewage sludge incineration ash that is produced as a byproduct. Next, PB would like to share on some of the observations from our past limited experience with hydroponics cultivation using the phosphorus recovered from our waste streams. Firstly, we noted that the sulfide recovered from our dewatering centric stream could not be readily dissolved to form nutrient solution for hydroponics cultivation. Secondly, we also observed the accumulation of contaminants inside hydroponics crops grown with dewatering centric mixed with nutrient solution and its negative impact on the growth yield of our crops. Here are some pointers to consider in your proposal submission to PUB for this problem statement. Firstly, the proposal should highlight the proposed technology to produce phosphorus in readily soluble form for developing hydroponics nutrient solution. Secondly, the proposal should highlight on the technologies for removing trace contaminants, including heavy metals and pharmaceuticals typically present in our waste streams. Thirdly, the proposal should cover on the proposed crop testing methodology. It should provide details on the proposed crop test setup, the basis of comparison with crops grown using standard commercial nutrient solutions, and the methodology to validate the absence of bioaccumulation within the crops grown. Fourthly, the proposal should highlight how the overall phosphorus recovery scheme can be easily integrated with PUB's existing used water treatment processes. Last but not least, the proposal should also provide some initial assessment on the techno-economic analysis for scale-up of the entire process. Lastly, this slide here summarizes the expected outcomes from the project after award. For information, PUB will be providing batches of the selected waste sample to the awarded applicant to conduct the piloting. The piloting scope shall include, firstly, the characterization of the waste samples provided by PUB. Secondly, the development of a prototype to convert the phosphorus from PUB's waste samples to phosphorus in readily soluble form. Thirdly, the development of hydroponics nutrient solutions using the recovered phosphorus in step 2 as the main phosphorus source. Fourthly, the development of hydroponic crop tests set up to grow crops using the nutrient solution and to ascertain if there's any visible difference from the crops grown using existing commercial nutrient solutions. Lab tests shall also be conducted on the crops to ascertain the absence of bioaccumulation. Lastly, techno-economic analysis shall also be conducted for the scale of the entire phosphorus recovery scheme. PUB would like to point out that if the pilot is successful, both PUB and SFA may consider to further scale the solution with the solution providers. And with this, I've come to the end of this sharing. I hope that the sharing has provided more clarity on PUB and SFA's problem statement and what we are trying to achieve. We look forward to receiving proposals on the ideas that you may have.